Assalamualaikum and a very good day. I'm Faisal from the School of Ocean Engineering, University Malaysia Terengganu. Welcome back to our UMTMOOC program for the subject of Naval Architecture and Shipbuilding. In this video, I shall introduce the principal dimensions of a ship and to identify coefficient of form of a ship. The objectives of this topic are as follows. First, to introduce the principal dimensions of a ship. Second, to identify the coefficient of form of a ship. Number 1 is baseline, or in short, BL. Basically, a baseline is a line lying in the longitudinal plane of symmetry and parallel to the design summer load waterline. It appears as a horizontal in the lateral and transverse view of the hull surface. The baseline is the longitudinal axis, or the x-axis, which in the system of coordinates of a ship hull. Secondly, is the reference waterline. In the international standard of ISO 7462, this reference waterline is basically the summer load line. What is summer load line? Summer load line is the waterline up to the ship that can be loaded in seawater during summer, where the waves are lower than in winter. The load line may change in the later design stage, since this reference waterline is defined in the early design stage. Therefore, the reference waterline are called DWL or design waterline. Next is Aft Perpendicular, or called Aft Perpendicular, which bear the symbol AP. This line is drawn perpendicular to the waterline through the axis of the rudder stop. In recent ship design trends, the usual location to place AP is at the intersection of the outermost part of the molded surface and the load line. The forward perpendicular, or noted as FP, is drawn perpendicular to the load line through the intersection of the foresight of the stem with the load waterline. FP is drawn on the outer side of the stem. The distance between the after and the forward perpendicular measured parallel to the load line or x-axis is called length between perpendicular or LPP. The length overall, LOA, is the length between the ship extremities. The length overall submerged, LOS, is the maximum length of the submerged hull measured parallel to the design load line. Station. Station is defined as the transverse section of the hull surface passing through that point. The station placed at the half LPP is called midship. Next, the molded depth, D, is the height above baseline of the intersection of the underside of the deck plate with the ship side. Next, the molded draft, or draft, T, is the vertical distance between the top of the keel to the design summer load line, usually measured in the midship plane. Even when the keel is parallel to the load waterline, there may be appendages protruding below the keel, such as multi-beam sonar. Therefore, we need to define an extreme draught that is the distance between the lowest point of the hull or of an appendage and the design load line. Next, the molded volume of displacement. The molded volume of displacement is the volume enclosed between the submerged molded hull and the horizontal waterplane defined by a given draft. This volume is noted by inverted triangle, a symbol known in English language as del and in European literature as nebula. This is basically part of the hull below the waterline or the submerged hull. Some large ships has its deck with transverse curvature that facilitate the drainage of water. The vertical distance between the lowest and the highest point of the deck is given transverse section is called camber. In a vessel, sometimes there is this longitudinal curve. Such curve is called shear. The deck shear helps in preventing the entrance of waves and is taken into account when establishing the load line in accordance with international conventions. Next is the coefficients of form of a ship. In ship design, it is often necessary to classify the hull and to find relationship between forms and their properties, especially the hydrodynamic properties. The coefficient of form are the most important means of achieving this. By their definition, the coefficients of form are non-dimensional number. The block coefficient is the ratio of the molded displacement volume to the volume of the parallelepiped rectangular block with the dimension L, B, and T. Next, the midship coefficient, CM, is defined as the ratio of the midship section area, AM, to the product of the breadth and draught, BT. The prismatic coefficient, CP, is the ratio of the molded displacement volume to the product of the midship section area, AM, and the length, L. CP is an indicator of how much a cylinder with constant section AM and length L is filled by the submerged hull. Let us note that the waterplane area by AW. Then we define the waterplane area coefficient by the submerged hull. We finally come to the end of this topic. I hope you can understand and enjoy learning. Thank you for watching this video. See you again.